Well, good morning. This is Jayaprakash from the Computer Technology Department. Today we are going to see about stack and its operation. Before going into the stack, let me know what is meant by data structure. A data structure is a way of collecting and organizing the data for the effective manner of telecasting the content. That is called data structure. And the data structure has been classified into two types, that is linear and non-linear manner. Linear in the sense data are arranged in the order fashions, where non-linear it is not arranged in the order fashions. For example, in the linear data structure we can say it's a stack, queue, then linked list. These are the some examples of linear data structure. And the non-linear data structure consists of tree, graphs. These are the list of elements are organized by non-linear fashion. Okay, let me get into the stack. A stack is a linear data structure which is used to collect the information and put it into the stack, which works on the principles of that is the data which we put last in, which gets first out. That is called LIFO, or we can say like this is FIFO, that is first in last out. The data which we put first will be taken last, so it is called as FILO. These are the two methodology, or we can say the principles for working as a stack. And stack operations we can do push as well as pop. Then third one is top. Push is nothing but inserting the element into the stack or adding an item into the stack. That is called push, whereas pop is a removing of an element from the stack or deleting an element from the stack is called pop. Whereas a top that indicates the element which is stored at the first place of the stack is called top. The top pointer, while inserting the element, the top pointer always keep on moving by incrementing the value by 1. Okay, these are the stack operations. Push functions which used to add an item into the stack. Yeah, when the stack is full, it stores the conditions that is overflow. We can't store the data into that. When it is not full, we can insert the element into the stack. That is called push. Whereas pop is the removing of an element or deleting of an element from the stack. When the stack is empty, it shows the underflow. There is no element into that, we can't delete any element. If the stack holds an element or an item, we can remove or delete an item from the stack. That is called pop. Then third one is peak, or otherwise we can call this as a top. It returns the element which is situated in the top of the list is called peak or top. Then the fourth condition is empty. If the stack is empty, it returns the value true, otherwise some element is stored into that stack, so it returns the value false. Okay, these are the block structure of a stack. It consists of several layers. All the operations in the stack we can use at only one end, that is called top end. We can insert as well as delete at only one end at the top of the stack. Okay, stack is a linear data structure. We know that the stack is a linear data structure. By using the push function, that we can insert a new element into the stack. Whereas a pop function is used to delete or remove an element from the stack. Both insertion and removal of a data or item takes place at the top position. When the stack is full, it conditions shows that it is an overflow. If it is not full, it shows the condition as underflow. Some of the applications of stacks are reversing a string. If we store the element into the stack, we can reverse the order by using pop operations. That is called, these are the applications, that is reversing a string, parsing, and the evaluating of expressions. That converting the expressions into the postfix, prefix, or infix form. So these are the applications which we use in stack. When we implement a stack, we can implement by using array as well as linked list. Whereas array is quick, but they are limited in size. Then they switch over to the linked list. The allocation and deallocating the values in the linked list takes place because of linked list using pointer, so it is not in limited size. Okay, these are the how we can implement the stack operations. Initially the stack is empty. I am inserting the element 1 and it stores at bottom of the table, and I am inserting a new element that is 3, it stores into the second stage of the layer. By inserting the element into the stack, we use, if stack is full, it returns the value null. If we want to store the data into the stack, by incrementing the top value, top equal to top plus 1, we can insert the element into the stack. This is the push operations. I am inserting the A, B, C, D. These are the values I am inserting the data, and the cursor pointer always moves level by level. At the end, the element which I stored last at the place, the top will be positioned. And these are the algorithm for the pop operations. While removing of element from the stack, we use top equal to top minus 1. That is decrementing the value by 1. This is, if stack is empty, we can't delete any element into that, so it's returned the statement null. If it is stack is containing any element, that is stack of top of containing any element, that is data, we can remove an element that is top equal to top minus 1. These are the pop operations that we can add some items, that is A, B, C, D, D, E, F. Then we can remove the element by one at the top position. Both insertion and deletion takes place at only one end, that is called top end. Thank you.